Uh, so the session is now being streamed live on YouTube as well. So welcome all. So the first thing is a simple question. What comes to your mind when you hear this word acid? You can reply on chat. You can speak also and give an answer.
Dangerous.
Corrosive.
Sorry, corrosive. Yes. Anything else?
मैम चैट में भी आया है सॉल्ट टेस्ट
Acha, somehow I can't see chat. Just a sec. Okay, now I can. Sour taste, corrosive, H plus ions, dangerous to us, useful in many ways, highly concentrated, H plus ions in aqueous solutions. Yes. So all these answers are correct. Of course. The thing is, when acids are started for children in class 6, or sometimes in other classes. Kajal Kushwaha, you are writing on the screen. Please try not to. So children are, okay, a molecule which can donate a proton. Yes, all correct answers and many answers coming from your understanding of chemistry. But when children think of it from the point of view of children, when they are introduced, they are introduced with only the sour taste. And indeed, the word acid comes from a Latin word acidus, actually meaning sour. And we all are familiar with this taste. So let's first name some acids around us quickly.
Citric acid.
I'm somehow not hearing.
Citric acid, ma'am.
Okay, citric acid, lactic acid, acetic acid, nitric acid. I see around us means we will not talk about chemistry labs, but in daily life. So, okay, when you say tartaric acid, oxalic acid, can you also say which substance around us contains this?
So lemon, citric
Tartaric,
acid from lemon.
yeah. So tamarind, tomato, yes. So I mean, actually, nearly all grapes, tea. Okay, I personally don't know which acid is there in tea, but formic acid is where, and tannic acid is where. So it will be good. I mean, okay, particularly for children or some of us who may not be familiar, where is this acid found? It's so yes, red ants have formic acids. Actually, all ants and most insect bites contain some kind of acid, and that also gives us a clue as to how to handle a insect bite. So tannic acid in tea, yes. So okay, so uh, here we have put in some. And of course, there are many more, but we are surrounded with acids. But my question is this: are we interested in acids because of their sour taste? Why are we so interested in acids? I mean, why is it an important category of substances? Okay, so I get a response. Acids help in digestion. Then there are many uses. Yeah, definitely correct. But then there are multiple other things which help in digestion, and they're like anything that is around us we are using means it has many uses. So, are acids important because they have many uses? I mean, why is it such an important category? See, these are important questions for us to ask. I am deliberately raising this question because when we teach children acids, all we tell children is, they are sour. So then any intelligent child will think, why are we're not talking about sweet taste and salty taste and other tastes, chili tastes. So it's not the taste of the acid. Okay, acids do have sour taste, but we are not interested in them because of the taste. And secondly, it would also be dangerous to taste all acids. I mean, you can never taste lab acids. You shouldn't, in fact. So this is a very important question, why acids are important. And actually, some of, and they are actually important category of chemicals, a very important category of chemicals. And it's only after understanding their chemistry that uh, we understand why they become so important. But one important question which had come here is they help in the digestion. Can you tell me how they help in digestion? React with other elements. Okay. So, I mean, is it acids are used in our stomach because of their reaction with food, neutralization effect, provide acidic environment to pepsin, break down complex food substances. Actually, acids are not doing the job of breaking down. What Upasana has said is a very, very important um property, that acidic environments to pepsin. What is pepsin?
Amino acid?
Enzyme. It's an enzyme in the stomach.
Enzyme. So actually, enzymes which are helping digest food. So then, why is then enzyme is breaking down the protein, correct? So what is the job of acid there? How is it helping the enzyme?
Enzymes are active in acidic medium.
Correct, correct. Actually, that's what. So our body is using the uh, acids and bases, the acidity or basicity, alkalinity, or the medium to tightly control which enzyme will act and which will stop. So some enzymes will act only in acidic medium, others will act only in basic medium. So if action of one enzyme has to be stopped, immediately the body changes the medium. So the body is using actually acidity and basicity for tightly controlling the reactions which are happening, because with the help of enzymes. So I mean, so this is one of the methods through which the body controls processes inside. I mean, that is about the body, but otherwise, the chemical properties of acids and bases actually make them a whole large number of important uses, and we will come to some of them afterwards, after their properties. But which atom do acids have in common? So as you people are saying, activation. Yeah, H. So H is what actually characterizes an acid. So it's like you people said, hydrogen ion. But see, children are in early classes will not know this. So in early classes, we can't say all this, but yeah, later it's like acids give us hydrogen ions, as you have already said. So every acid will give hydrogen ion, or some people even called it proton. And we will see why this giving hydrogen ion becomes a very important property, releasing hydrogen ions. So now, can you name some bases around us? around us, which means common daily life. Sodium
Flaked
hydroxide,
lime,
not around us.
flaked lime, Gelusil,
Sodium
Gelusil,
bicarbonate.
flake lime, soap,
Sodium
baking,
bicarbonate.
baking soda,
baking soda. Somebody said sodium what? I
Sodium
missed
bicarbonate.
sodium bicarbonate. Okay, carbonates and bicarbonates. Yeah, there are various kinds of sodas. So, I mean, these are some of the common ones: Gelusil, Digene, soap, baking soda, washing powders.
Window cleaner. Window cleaner.
Which cleaner?
Window cleaner. The glass cleaner. Ammonium
Window cleaner.
hydroxide.
Ammonium hydroxide. All right. The thing is, see, once again, they are used as cleaners because of their properties. What property makes them good cleaners?
With the cleansing property, maybe.
Yeah, I mean, they have this soapy property, and also, of course, they combine with certain things, but they are soapy, and they actually combine with um, your greasy dirt. So they combine with grease, and that's why they have affinity to dirt, because of, yes, they're simply slippery, but they have this, they combine with grease easily. That's why, and they give the hydroxide ion. So whenever bases are dissolved in water, they give the hydroxide ions, OH ions. So basically, anything that gives hydrogen ions, H plus ions, that's acid, and anything that gives OH ions is a base. And it's this chemistry of these two which gives them their powerful properties, and also their interaction with each other. So, I mean, here we've just shown a few. For example, Gelusil is hydroxide of aluminum and magnesium. Digene is hydroxide of magnesium. Soap has one component as NaOH. Soap is not only NaOH. So,
Hydroxide also. KOH.
KOH also. Okay. Yeah. So basically, bases are giving all of us hydroxide ions, and we have to see that this whole story of hydrogen ions and hydroxide ions, where does it start? So it begins with water. So water, as you all know, is a molecule with oxygen and hydrogen, and oxygen and hydrogen are sharing their electrons. But because the oxygen is a bigger molecule having more protons, poor hydrogen has a single proton here. So this electron pair is pulled more towards, see, there are 8 protons here, and here there is a single one. So these 8 protons will pull these shared electron pair towards itself. So more pull that side, because of which oxygen, because of this pulling of this electrons on its side, develops a mild negative charge, and hydrogens on here develop a mild positive charge because it's a small charge. It's that word delta is written, that letter delta is written. So it's weakly positive and weakly negative, in spite of being a covalent compound. I mean, this you would know as chemistry teachers, but important to tell children that it's a covalent compound. In covalent compounds are not polarized. They don't have positive, negative side. I mean, they don't have ions actually. But here, slight negative charge here and slight positive charge here makes water a polar molecule. So, or it has like charges on its 2 ends, and therefore some water actually breaks up into 2 ions, a positive ion and a negative ion. I mean, only some of it, not all of it. Water gets ionized. And interestingly, as somebody had pointed out, I mean, this one, H plus ion, where hydrogen has lost its single electron, is Actually, just a proton. Just a proton, or at most it will have a neutron also, but single proton. Now, single proton here and one hydroxide ion here, single proton here cannot stay alone. It's because there are enough charges around it. So it's like very difficult for a single positive charge to stay alone. So it goes and sticks to another water. I mean, it'll go and stick to the negative side of water. Because the oxygen itself is a little charged, so it will go and stick to that and make this ion, which is H3O with extra plus charge, which is called the hydronium ion. So H2O plus, so this H which was broken goes and sticks to another water. So that's why instead of H plus ions, actually, I mean, hydronium ions is also talked about, though it's not necessary that we tell this to children, and depending on the stage of children they are in. So it's like this. So if there are two waters here, two water molecules, one of them breaks up. So, and it's H plus goes and joins here. So we have H3O, and the other one remains as OH minus. So it breaks up into these two, H3O and OH. But the interesting part is that this reaction is not only forward, it's also backwards. So the forward and backward, both reactions keep happening all the time. So some water will join up and break up like this. Then once again, these two will join up and go back and become plain normal water. So some water ionizing, some water deionizing. So both processes are on all the time, so that at one point of time, only a few ions are present. So like I just said, all water molecules do not break up like this. Only very few do. So what is your guess? How much water breaks up into H plus ions? Any idea? Normal water, ordinary water. 1 out of 10, 1 out of 100, 1 out of 1,000, 1 out of 10,000, 1 out of million. Any guess? So, okay, Kyle has said, let me count the zeros. See, it's become so hard. 1, 2, 3, 4, 5, 6, 7. Okay. Yeah, so an 8-digit number. So Kyle has said 1. So yes, as Balachandar has also said, 10 to the power 7. Bharti is saying 1 out of 100. So actually, before, how many break? Let's see in 1 liter. In 1 liter, how many molecules are there? So it's like so many zeros. Actually, it's like 24 zeros. I mean, it's for a special reason that we have made the center, like these 8 zeros colored green. They are not different from any other. It's almost like if you wrote 3 and wrote crore ahead of it. 8 zeros, 8 zeros, 8 zeros, 8 places of the places. So it's like so many molecules are there in 1 liter of water. So in 1 liter of water, so many molecules, and out of this, out of 1 crore, only 1 molecule breaks, as some of you said. It's like we used this number simply because it's easy to remember. This crore. So 1 crore. So out of 1 crore, one molecule breaks up into H plus and OH ions. This is the normal water. And there is a way to write hydrogen ion concentrations. We can write all this, or we can put square brackets. So if we want to write this hydrogen ion concentration, we can write it 1 out of 1 crore, which can also be written as, so this square bracket says concentration. This is 1 upon 1 crore or 1 divided by 1 crore, which is same as 1 into 10 to the power minus 7, as somebody just said. So this power 7, it's a negative power. This is what we say pH. It's actually hydrogen ion concentration, but expressed as the exponent, as a negative exponent. And Bharti is saying ionic product of water. Bharti, what do you mean by ionic product?
Product of concentration of ions in the solution.
Yes, concentration of ions in the solution. That's correct. So yeah, so that concentration we can write as 1 into 10 to the power minus 7. So this is normal water. This 7, negative is not written against it. This 7 is actually what is power of hydronium ions, or like it's pH. So now we will show, actually, I mean, well, you can also write it as minus of log 10 of hydrogen ion concentration. This is formal definition, but actually children do not understand this. Children do not understand log easily, even though it's a simple concept, but it makes it sound very complicated. So instead, we are giving you a method which is visual and easy for children to understand. So suppose you have 10 normal particles, out of which one is ionized, one is broken. So how will you write it? 1 out of 10, right? So 1 in 10. So if we write it as concentration of pink, it will be 1 by 10. So in terms of power of 10, how much is this? Yeah, so we can also write as 0.1 or 1 into 10 to the power minus 1. Yeah. So what will be the pH of this if we see this water where 1 in 10 is broken, what will be the pH? pH would be
pH is equal to 1.
Yeah. So pH would be 1, and it's a very high concentration of broken ions. And see, I mean, like so many pinks you can see amongst green, lots of pink particles. Similarly, I mean, this is so 1 in 10. If suppose we say it is 1 in 100, so how will you write it? Can you
1 by
quickly write?
100
Yes, 1 by 100, which is same
or
as
1 into
1
10
by
power
10 square.
minus 2,
yes, 1 into 10 to the power minus 2. So the pH
or the
is
pH value is 2.
2.
pH value is 2. Yes, great. So you are teachers, you are quickly telling me this, but children will take some time, but it will be good if you let children write it by themselves so that they become comfortable with this idea. 1 in 100, 1 out of 100, and which can be also written as 0.01, can also be written as 1 into 10 to the power minus 2. The children are quite confused when it comes to decimals, exponents, and all that. So give them this practice. So
Ma'am, I have
can you
a
tell
doubt.
me? Sorry, yeah,
Ma'am, I have a doubt.
yes, please.
It's Gayatri. And how to make the children understand pH value? pH is 0.
Okay, so you tell me. See, pH 0 means 1 upon 10 to the power 0. In fact, this is something you should ask children themselves. So what is 10 to the power 0?
1.
1. So
1.
it's a 1 upon 1, which means 1. That is, which means actually, this is saying one is broken. I mean, one out of one is broken, which means all water is broken into its ions, which is an impossible thing to happen. I mean, all water does not break because there is a opposite thing also going on, no? If some breaks, the other joins back. So it's not even possible that all water breaks up into ions. So it's an impossible situation. That's why we never see pH 0.
Thank you, ma'am.
Yeah, welcome. Any other question?
No, ma'am. No, ma'am. I just had a confusion how to just make the children understand pH 0. So only I
correct.
asked.
See, yeah. No, it's good that you are asking. And actually, I mean, okay, we as a foundation, we continue to insist, let children ask. Let them ask anything. It should be okay to in the class to ask any questions. And if children are confused, they don't understand. Of course, we also have to try that we can somehow explain to them, reach their level and explain. But also, if we allow them to ask freely, sometimes children come up with very, very uh, brilliant questions, very, very good questions, and very good comments. And their level of engagement with what we are teaching is amazing. And we ourselves experience that all the time, and it feels so sad that I mean, our system terrorizes children into being fearful of science, being afraid of science, and hate science. But anyway, so
Yes, ma'am.
so sorry, yeah, somebody was saying something.
Yes, ma'am. I do agree with you.
Uh,
Sometimes children
uh,
are very much scared.
Absolutely, Gayatri. Children are so scared of science. Oh my God. And particularly chemistry. Chemistry is the most hated of all sciences. Do you agree?
Yeah, ma'am. Yeah, ma'am. Yeah.
Correct.
Mm.
So that's why. So we are also from our side trying hard that chemistry is appreciated for the beautiful thing it is. I mean, all sciences are beautiful in their own way. So, but without chemistry, science is not even lame. It cannot even stand. So anyway, so a very, very obvious question is, so if pH is 2, hydrogen ion concentration is less or more than pH 1?
It is less.
Correct. So see, this is something children need to appreciate. Not only you ask, it will be good to show them. If you can show, so this is pH 2 and this is pH 1. I mean, so many pinks, and here there is a single pink. So this is a lot of pink particles, and here's a single particle. So look, and so one important thing is this. This is a lot, and this is a, and a single change in pH means 10 times change in concentration. Here the concentration is 10 times less. This is something hard to appreciate, but this acid, so hydrogen ion concentration means acid. The more the hydrogen ion, the more stronger the acid. This acid with pH 1 will be not twice, but 10 times as concentrated. Heavily concentrated. It's a very, very concentrated acid. 10 times as much as pH 2. Similarly, we can now talk about pH 3. So, how do we write it? 1 out of, this is 1000 colored, I mean, green balls. So 1 upon,
1/1000.
yes, which is same as
pH 3.
1 into
3,
10 power minus
1
3.
by 10 to the 3.
yes, 0.001 which is same as 10 to the power minus 3. So pH becomes 3 here. But yeah, the important point to again show children that, look, the number of this pink has dropped so much. pH has dropped just by 1. But the hydrogen ions are so much lesser. See, we have not created a visual other than this one, like 1 in 1,000, but I mean, it becomes very hard to make 10,000 dots or 100,000 dots. But so basically, an increase in pH number means less or more.
More.
Less,
Less.
less.
As pH increases, lesser and lesser, and very much lesser, till we reach 7, where you have 1 out of 10 to the power 7 particles, and pH becomes 7, and we say that water is neutral. So neutral water has very little, very little hydrogen ions. And I mean, this table we have deliberately created. So just try comparing. Here, so the same thing which we have been discussing, we have just written in numbers. So this is ordinary water above. 1 out of 1 crore is broken, which means pH is 7. If pH becomes 6, I mean, either you can go from above to below, or maybe you can go from below to above, whichever way. So if pH becomes 6, now 10 would be broken out of the same amount of water. 10 would be broken, pH becomes 5, then 100 would be broken. And as you go down, I mean, pH is 4, and it becomes 1,000, and pH is 3, then 10,000, pH is 2, then it is 100,000, and pH is 1, then it is 1,000. I mean, so just compare the numbers here on the left hand side. Compare, I mean, this pH, okay, look at this pH acid having only 10 here, and this pH having, I mean, this is 10 lakhs or 1 lakh? 10 lakhs, right?
Lakhs, ma'am.
Am I correct? Yes.
10 lakh,
So this
10 lakh,
has
ma'am.
10 lakh. So think of it, I mean, here only 10 ions, and here 10 lakh ions. So this acid, the acid here with pH 1, is like hugely, massively strong. It's not a question of 10 times or 4 times or 5 times. It's like where 10 and where 10 lakh. So when you're dealing with pH 1, you're dealing with a very strong acid, and it's so since it's a logarithmic scale, a scale which jumps by 10 times every time. So therefore, the numbers become so large, and that's the important thing for children to appreciate.
So, ma'am, it is Mushtaq Ahmed from Kulgam district of Jammu Kashmir.
Yes.
So, ma'am, at pH 1, we may say it is 10% of the total ions are of H positive then. Because when we say 10 lakhs out of 1 crore, so we have a good number of active ions.
Yes. Yeah, it will become
Okay.
10%. Yes.
Thank you.
But the thing is, these numbers are hard to appreciate. What we have been trying to do is somehow make children appreciate this. I mean, just writing it as in those numbers, the whole idea is not appreciated well. So whichever technique you use or we use, we'll have to somehow try that children appreciate this fact.
Definitely, ma'am.
Yeah, and 1 pH acid is so strong it can kill. I mean, it can burn through your whole skin and your muscle and everything. It's a very
Definitely.
strong acid we are talking about. Yeah, and interestingly, stomach acid is roughly pH 3. And stomach acid is also very strong. When I think about it, I feel scared. But yeah, our body protects itself.
Definitely, ma'am.
And actually, this is also, our job as teachers, that when somebody is teaching chemistry and somebody is teaching biology, or often the same person is teaching, we should connect across sciences, isn't it?
Definitely, ma'am.
So that it's
Definitely.
appreciated better.
Definitely, ma'am.
Okay.
In fact, ma'am,
So now, yeah.
sorry to interrupt, ma'am.
No, please carry on.
In fact, when I teach chemistry, I personally, I made my students remember one thing, one proverb. Where there is geometry, where there is chemistry, there is geometry. Because without matter, you don't have any, so nothing is possible without chemistry. So we try to engage them with this thing, and we give them hands-on activity regarding this pH scale and pH of different substances. In fact, in 10th class science, this topic acids and bases, there is importance of pH in our life. So we give them good examples of this sitting nettle we do have in Kashmir, in large abundance. That Attica dioica is the plant. When it comes in touch, it gives blisters, and probably there is formic acid in that. So we give them examples. When we came in touch with that plant, we instantly, if we spray this sodium bicarbonate or we use some detergent, so that way it becomes very much interesting for the children to learn about the pH changes. And in fact, pK is one of the best examples we can engage them, and so that they come from this. When we talk of teaching science, it should be from concrete to abstract.
Yes, absolutely.
From concrete to abstract.
Absolutely.
So we try first of all to build some concrete concepts. When concrete concepts are clear, and then our youngsters will definitely understand abstract concepts very well.
Absolutely. And that's why, I mean, good teachers struggle. They struggle to find examples, struggle to find means and ways so that children appreciate what we are giving them. Yes, very nice.
Definitely.
Very nice.
And again, I am very much sorry I was a bit late because I was busy with Nimaz. It is around 6:15 तक हमारा था, मैं busy था, so I could not join. I request you, if you have some recording of this when you started this session, so you please share that.
Yes. Actually, this is live on YouTube. It will be it will be stored on our YouTube channel. I'll request my colleague Manisha to please put the link in the chat box so that it will be stored. So you can always have a look.
Thank you, ma'am.
Welcome. So now how about bases? How do bases work? As we said earlier, any base breaks up into a positive ion and a OH ion. The thing is that if by class 9 or 10 we can help children think in terms of positive and negative ions, it will help a lot. It will really help them to have that chemical imagination, and that's what acids and bases help us do. I mean, as we talk about their reactions and all that, so which is the positive ion, which is the negative ion, and what is doing what. And because ultimately the salts will also be made out of these ions recombining. So once they start thinking like that, it's almost like a game. But here, the important thing is that it's only in solution that these two ions will separate. And that's why bases actually show their properties when they are in solution as alkali. So that's also something worth knowing. I mean, of course, if you hold a base as a solid, it will dissolve. Some of it will dissolve with water in your skin. So then also it will behave as an alkali, but without dissolving, it will not act. And the important question is, okay, first I'll ask this. Why do you think adding a base to water makes the hydrogen ion concentration become less?
Because bases provide hydroxide ions in solution.
So how does that reduce the hydrogen ion concentration?
The number of OH minus ions increase compared to the H plus ions or the hydronium
So-
ions.
Correct. So OH ions will increase. So how does that decrease the hydrogen H plus ions? See, we are saying
trapped.
here, so
They are trapped with OH ions, and then water is again H2O is formed. Is it so?
exactly.
The H plus
Exactly,
ions
exactly.
will combine with the water to form
What-
hydronium
OH
ions, which may be in less number.
Actually, the reverse reaction. See, we know that we said no, the reaction is going both ways, always. But if so some of the water is always broken like this, H plus and OH ions, and now you have increased this concentration. So you increase this. Now this when you have added a base, you have added more OH ions. And what will these more OH ions do? They will pull other H plus ions. They'll pull more H plus ions towards themselves and create neutral water. So there's this backward reaction of making the neutral water will become stronger, reducing the quantity of H plus ions. See, this is one important point which is missed often and not mentioned properly. So
It is common ion
it's a-
effect, is it, ma'am?
sorry.
Common ion effect.
No,
Common
it is
ion
not
effect.
common ion. No, it is not common ion.
See, I don't even know what is common ion effect. All I'm saying is that this reverse reaction becomes stronger because of extra OH ions. These will pull hydrogen ions towards themselves, and this backward reaction will become stronger.
In
So-
fact, it will go towards this. It is a sort of equilibrium concept. Equilibrium concept.
Yes, correct.
Yeah.
So therefore, now your extra OH ions will lead to further reduction. There was 1 in 1 crore in ordinary water, and now you have added more OH ions. So there will be even less H plus ions than normal water, than neutral water. So pH of alkalis should be what now?
More than 7.
More than 7. Yes. So they'll be more than 7. And I mean, we have deliberately put these numbers so that the whole thing, I mean, now we can see them as a series beyond 7 to 14. So we had 1 out of 1 crore is 10 to the power minus 7. Now it is 1 out of 10 crore. If you like, even if it becomes lesser than that, then the first one becomes lesser. So it is 1 out of 10 crore will become pH 8. 1 out of 100 crore will become 9. 1 out of 1000 crore will become 10. So it's just adding more zeros. I mean, thinking in terms of zeros isn't easy. And that's why this like 7, 8, 9, 10. But all that we need to understand is every time it's like it's 10 times more water in which there is one broken now. Every time. This is this much water. Now it's 10 times more water, which has one. Now it is still 10 times more water, and still. So this becomes a very large number. pH 14, a very large amount of water will have now only one H plus ion. So H plus ion is are becoming so much less. So like Uma Devi is saying, 7 to 14. Correct. So now, since we can't talk in numbers, firstly, we use the pH scale because it's simply 1 to 14. That scale is so convenient. And actually, you think if they had not made a log scale, just think how hard it would have been. If it did not have this, like the power of 10 wasn't used, then every time it's becoming 10 times, we would go crazy handling zeros. Too many zeros are coming in the picture. So simply pH scale simply goes from 1 to 14. So life becomes simple. And then, of course, the use of indicators. So from here, Preeti will take over. Preeti, you want me to show the PPT, or you'll show?
I will share now.
You'll share?
Yeah. Okay. So for like Anshumala ma'am, she talked about आपका hydrogen ions के बारे में बात हुआ है, hydroxide ions के बात हुआ है. But eventually it comes to आपका hydrogen ion. ये कितना है अगर वो 1 in 1
Preeti,
crore
sorry,
है.
Preeti, stick to English because some people are English knowing. Many people are come from South India.
Sure, ma'am. Okay. So far we have discussed about the acids and bases, the hydrogen ions, its concentration, and how we go to pH, that's 10 to the power, the negative power of the exponential. That was the pH. But as we saw, there were like large numbers. They were in 1 crore, in like more than that. But in daily life, or at the most, if you are kind of teaching to the children, then there is no way if we show, okay, this is the acid and these many hydrogen ions are there. So there we can't play with the numbers, at least for the children. So what do we do there? So we have like simplified to show or to kind of check if something is acid or something is basic. So there comes your pH scale and indicators. So pH scale, as Anshumala ma'am just told, it's from 0 to 40. So 7, that is neutral, as you will see in the middle. Less than 7, as you go from 6 to 5 to 4 to 3 or less, that is acid. The more acid we are going. And if the pH is more than 7, if it's 8, means it's slightly basic. If it's 9, 10, it's more basic. If it's 11, 12, that is kind of highly basic. So that's, I think, we are comfortable. But now, as you are seeing, there are different colors also. So what is it? What are these colors? How it's different? So that is just came from universal indicator, as we call it. Universal indicator, you can find it in the paper, or there is solution also. If there is any substance you want to check, okay, what is the pH of it? If you dip it in the water, or you kind of put the indicator into the substance, into the solution, so there will be a color, a change of. So as per the color, you can determine, okay, if it's dark red, it means it's highly acidic. If it's somewhat in between, it's yellowish, okay, slightly acidic. If it's greenish, then it's neutral. And now if we go towards higher pH, so it will be more blue. So indicators are usually those substances which helps us to determine if the given substance is acidic or it's basic. And depending upon the indicator, you will find the different changes. If there's color change, you can find in some cases. In some cases, there will be change in smell. So if we have to kind of summarize it, we can say that if there are indicators, what we are comparing is its presence of hydrogen ions or the concentration of hydrogen ions. If it's less than the normal, then it will go towards the acidic. If it's more, then it will go towards the basic. So these are just a few examples of indicators. Like obviously, like most of these we have taught in labs or something. But for children, we can show these if we are taking the class in school. So usually we have these in our labs. It can be in paper form, it can be in solution. So we can use the litmus paper or the solution to show how the color changes. If it's red litmus paper, it will change only in the basic to give blue color. If it's blue litmus, then it will change to red in. So these can be shown how it's kind of qualitative. Now we are moving away from numbers and just to check, okay, if the red litmus is changing, means would be basic.
Preeti, I would just like, Preeti,
Yes, ma'am.
I just want to share that example with universal indicator. Once, friends, we were just go back to one slide back to the universal indicator. I mean, I just wanted to share what happened in our workshop. You know, once in a children's camp, just 2 slides back. Before, yeah, this one. So in when face to face with children or teachers, we use universal indicator to make this series. So firstly, this series is so beautiful. So, and it is great fun for people. But the second thing is, in one children's camp, we had some dry ice with us, and we put some dry ice into the basic side. You know, I mean, the where we had alkalis. In the dry ice was constantly, bubbling away carbon dioxide, more carbon dioxide, more carbon dioxide, and it was constantly turning these solutions. I mean, on the right hand side, they were turning them into more acidic, and the solutions quickly kept changing color. I mean, from one color to other color to another color till they become bright red. It was so fascinating. In fact, we must be having that video somewhere. Manisha, can you locate that? Otherwise, I'll locate while Preeti is talking. Yeah, Preeti, sorry, please carry on. I just remembered that.
Thank you.
But yeah, that was beautiful actually. And there were children, they were so fascinating. Okay, what's going on? Were like so many colors just in a single beaker, and just by because it's being more and more acidic. So that's a good thing. Okay, so we have gone through this. So yeah, turmeric is another indicator. This can be found in like every home. This we use in making food, and most of us would see if there is a stain on any cloth from turmeric, and if you go to like so when it go for washing, so when it comes to the contact with detergent on the soap, it becomes reddish from yellow. But when you wash it off, then again it kind of changes color. So that is just one more example of indicator. These are few like hydrangea flowers. It depends the color of the flower. It depends on the pH of the soil in which it's growing. Same with hibiscus. So yeah, there will be many indicators. While taking class, so we can find some flowers around us or some substances that we can use and show to the children how these changes color in acids or in this. Okay. So now coming to the reactions of acids and bases. So we have before this we have discussed what do acids have in common, how they work, what bases have in common, how they work. So if you combine the two, if you mix an acid with a base, so what will happen? What will come from acid? What will come from base? And what will be the product? What will be the reaction? So that reaction is called neutralization. It means in simple language, we can say they are cancelling each other. Effect as in the acidity of acid is decreasing, is being neutralized, or the basicity of base is decreasing, or that is being neutralized. So as H plus ions, they come from acids, hydroxide ions that come from bases. So when both of these combine, they will make. So we can say if an acid and a base is reacting, we will get salt and water. Here we are taking example of like sodium hydroxide and hydrochloric acid. These are very commonly found acid and base in our laboratory, and we can do this reaction. But as both of them are colorless, so what will be going on, we can't see until unless we use an indicator. There we can use phenolphthalein, and it will give pink NaOH, and when you will kind of neutralize it, the color will disappear, or the opposite can do both. So NaOH plus HCl, if you will take the two, it will give NaCl and H2O. Inner chemical bonding, we use paper clips to show the reaction. So now I will ask Manisha, she will be using paper clips to show, okay, this is one NaOH molecule, this is one HCl molecule, and how they will combine and how the NaCl will form along with what. Manisha, can you? Yeah.
I just want to underline the importance of showing it with paper clips. Once again, this is something which helps children a lot. See, to us, it might sound trivial, but if you show just acid-base neutralization, I mean, you mix one liquid with another liquid, so the outcome is visible only as something forming as liquid, but what is happening at molecular level or atomic level is not understood. It is very helpful for children if the equation which is written only in letters, now you are showing what Manisha is showing is now two molecules, and the molecules break apart and make new molecules. So what is exactly happening at molecular atomic level is understood very well. So that's why that is the importance of showing it this way. Yeah, Manisha, please carry on.
Ma'am, excuse me.
Yes, yes, please.
It is. I first of all, I appreciate this concept of using this paper clips, but I would suggest one thing. It would have been better if we try to show to the children first the dissociation and then
Yeah,
association.
She's showing. Give her
Okay,
a chance.
sorry for the interruption. Sorry for the interruption.
Yeah.
So, I'm audible.
Yeah,
Yeah.
Manisha.
So this is HCl molecule. Blue clip represent H and orange clip represent Cl. So HCl, okay. And then this is NaOH molecule. Yellow clip represent sodium. O again represent red clip represent oxygen, and again blue clip represent hydrogen. So what will happen? This is HCl. It will be break, right? HCl, H plus and Cl negative. And here Na plus OH negative. This is a single OH negative ion.
Yes.
Plus join with OH minus and becomes water, and here Na and Cl becomes NaCl, salt.
Good. Very good.
Thank you, Manisha. So this is just one way. Yeah.
That video is ready.
Yeah.
The video.
Okay. Yeah. You are showing the video? Okay, let's continue with this and then we will come back to this. Okay.
Sorry, unable to show right now. Let's do it.
That's fine. We will come back to that later once we are done with this. Yeah. Okay. So in neutralization reaction, just as we show, there was NaOH and HCl. So that with the clips, it was just a representation how the molecules breaks or the dissociates, and then how they kind of combine to give salts and water. Usually, if that much not clarity is there, so students or the children, they will just remember, okay, they memorize, okay, that is NaOH, that is HCl, it is NaCl and H2O, okay, remember the formula, remember how the reaction goes. But if they do by their own hands, they break the molecules, then they recombine. So it just gives them a better idea, okay, how the reactions are going. Okay, so moving on, as you saw all in the reaction, so there is NaCl, and for salt, the positive ion or the cation, Na positive in this case, it came from base, as another part was negative OH ion that went with the H plus ion. And here the chloride part, it comes from S, and the H part obviously that went with the hydroxide ion. So salt, it is a combination of a positive ion or a cation and a negative part, that is anion. So, and each come from one from base and one from acid. So that was acid and base reaction, which is neutralization. Okay, coming to the next one. So what do you think will happen if we have a metal? In this case, we have taken zinc and there is acid. Here we have taken hydrochloric acid. So if we put metal in hydrochloric acid, what will happen? Usually, before
Hydrogen-
acid bases, we have usually the teachers already have discussed metals and non-metals, there's displacement reactions, the reactivity. So based on that also, this can be discussed. Okay, what will happen over here? Which can replace something or just a discussion. Now let's see if we do the reaction. So what will happen? Okay. So here we have taken dilute HCl, which you can see in the bottle. There is a test tube, and then we have taken zinc metal in the dish. There is balloon to collect the gas, and obviously the matchstick and the agarbatti. So initially we will take the acid in our test tube. Yes, precautions are very necessary. So usually if we are acids on bases, we don't hold by the hands. You use our test tube holder for these, or wear the gloves. Now we have put metal, the zinc into this, and you will see when you will do the reaction, they are just like bubbles have started coming out. The more you will shake, the more better the reaction will go, and the bubbles will be more clearly visible. Now to collect the gas, we have put a balloon over the test. So as the reaction will proceed, the gas will collect in the balloon. So this is after some time, just a little of gas has been collected. So just to make it more quicker and more better, the reaction, just give it a good shake. And as you shake, the more gas will be produced and it will get collected. So again, you can wait for some time, or you can just shake, and then after some time, we will have some gas in the balloon. Now to check which gas is it, so there are few tests that can be done for different gases. So here this is hydrogen, and how do we check hydrogen gas? Is if you take a burning kind of matchstick, or here we are taking a agarbatti, if you take this nearby the balloon, it will give a pop sound when the hydrogen will be burned. So that is the test for hydrogen. So like this, we can show that if we take zinc metal in hydrochloric acid, we have hydrogen gas and a salt. If we go with the formula,
Ma'am, sorry to interrupt, ma'am. With this activity, we can show one thing, because if we put out this balloon and release it in air, it will flow. It will fly rather, because hydrogen is lighter than air. So
Yeah,
that will be one more this conceptual thing for the youngsters.
yeah, you can also establish that hydrogen that is lighter than air, so it will flow around. It will not. Yeah, that
Yeah,
will be
but
done.
actually very little hydrogen is collected. I mean, it's like
Yeah.
you'll have a hard time putting a knot to that little balloon. See, one
Actually-
thing which yeah.
Actually, madam, I want to share to my dear colleagues that when I am using this activity in my classroom, I use this Wolf bottle, that two-necked bottle from chemistry laboratory, and we just first of all we tie a balloon on one side, and then put acid from other side, then put cork, and then we shake it. Maximum of hydrogen gas comes out, and then it is very easy to knot that balloon. So that is a very good. A lot of hydrogen gas is collected. If you can put more of zinc, you can put more of acid, and even you can shake the bottle, because through one opening you will add acid, and just put cork, and from the other opening where you have tied the balloon, the gas is collected, and beautiful balloons, big balloons are collected. Balloons of air are collected, and children enjoy very much this fun activity.
That's it.
Even for some activities, we have collected carbon dioxide also, and we have when we release that carbon dioxide balloon with carbon dioxide gas, and that just sticks to the ground, and it says clearly that this carbon dioxide is heavier than air. And then we do these type of experiments. We just put that carbon dioxide balloon towards burning this fire, and then we show them the fire extinguisher quality of this carbon dioxide.
Okay, Preeti, carry on. Or
Yeah.
see, the only thing I want to request to teachers is that any reaction that you are going to do, first ask children what will happen. Predict that if you mix this mm, ingredient with this or this reactant with this, what will happen? I mean, okay, metal and acid. So what should happen? So, I mean, okay, whether you're teaching metal and non-metals, it doesn't matter, or whether you're teaching here, the important thing is to ask that which atom is likely to replace which one and why, right? So that you give them a nudge towards chemical thinking. So that's important. Manisha, you're showing something?
So again, in this reaction, green clip represents zinc and hydrogen represented by blue clip, and similarly, fluorine
Manisha,
represented by
it's like pretty clear, so you can quickly do it. I mean, like
so yeah, Zn is like zinc is more, I think, more reactive with the place, or even HCl will convert it to H plus and Cl negative. So Zn will combine with Cl, but again Zn is 2 plus, it needs one more chlorine.
so, friends, you see, this is the important part. Why here, if children will do it with pins, the balancing of equation is not just mechanically counting. They can see that zinc has 2 valency, so now it will require 2 Cls. So when they are making the new molecule, so 2 Cls are required, so they'll have to take 2 HCl. So it becomes, instead of mechanical balancing, the valency part comes in by itself. I mean, they have to think about it, right? So
Sure, sure.
that's why this exercise is very valuable.
And by
Yeah,
this
please
we
carry
can
on.
explain
Yeah.
like the connection of Cl and Zn. Like Cl and Cl is not connected with each other, but we are connected through Zn molecule, Zn atom.
Okay. Moving forward. So we can say that if there is an acid and a metal, so if they react, and if metal is more reactive, so it will give a salt and hydrogen gas will be released. Okay. But what if we take a base with a metal? So now if you will see, like in all bases, there is some metal, there is like sodium or there is potassium, and then you are taking another metal. So even we can ask children like, what do you think? Any reaction will happen? Because in both the reactants now you have metal. And if the reaction will happen, then what will be the product? So we can ask the children to kind of put their chemical thinking to the process, or just by guess, okay, what would happen? Why would it happen? So here we have taken an example of sodium hydroxide, NaOH, and aluminum.
So you can ask Preeti to ask the group.
Okay, okay. So what do you think? Any guesses if we take NaOH, or if we take a base and a metal, so any reaction would happen? You can
Yeah,
put
ma'am,
your
it
responses in the chat.
gives out hydrogen and sodium aluminate is formed.
Sodium
So
aluminate is formed and hydrogen gases.
yeah,
See,
ma'am.
this is something already we know because we have read in the textbook. See, the point here
Actually,
is, it is
we
important.
say that sodium hydroxide is highly corrosive, so cannot be stored in aluminium containers. The reason is they to react with each other. So the aluminium container is used up and it forms holes. Like
That's a
reasoning.
very good example.
Actually,
But the
when
thing,
children asked why we need to store these chemicals in glass bottles, then I was saying that if you store acid in a metal container, what would happen? Like they dropped some acid on the floor on their desk, metallic desk, to observe very drop, one small drop of it. I said some sort of same thing will happen with sodium hydroxide also, or potassium hydroxide too, because they are very highly corrosive.
Yeah, so here you are showing the practical side of it, which is very good. But if you want children to think about like a chemist, think like a chemist, then say if I am like posing, I'm being the devil's advocate, I would say base and metal should not even react with each other. I mean, why would a base and metal act? Because base already has a metal. So here's NaOH already has a metal. So why would it act with aluminum? It shouldn't react with aluminum at all. So what would be your answer to that?
Reactivity of metals are
Activity of
different.
metals.
Sorry, say that again.
Reactivity of metals are different.
But sodium is actually more reactive than aluminum. So then this reaction, when you mix sodium hydroxide with aluminum, the reaction shouldn't happen. Why is it happening at all?
Actually,
Yes, Mustaq, you are saying something.
Maybe formation of H plus ions, which are again react with metal to produce hydrogen gas, ma'am.
I didn't understand the reasoning. Say that again. Preeti, will you stop sharing once?
Yeah, yes.
I want to see who's speaking. So, I mean, yeah. So who was speaking? This was
Ma'am, this is Balchandra from Telangana,
Yes,
ma'am.
yes, please. Yeah.
When we take in water, NaOH solution, there may present of H plus ions. Little bit H plus ions will react with that aluminum to produce hydrogen gas, ma'am. I think.
Yeah, but there is not a little bit of hydrogen produced here. A whole lot of hydrogen is produced. Actually, much more hydrogen is produced much more easily here. In fact, this reaction we will show, we have a video. A large amount of hydrogen is produced, and actually, I mean, see, on the face of it, it seems as if this reaction should not happen. Why should the aluminum cannot replace sodium? Sodium is so much more powerful, so sodium will want to remain as ion, and aluminum just cannot take its place. It doesn't actually. Aluminum does not take sodium's place. There is one metal, and which is a stronger one, and here is a metal poor thing, much less reactor. So why is the reaction happening?
actually, that aluminum shares its valency with oxygen, ma'am. Both sodium and aluminum, they share the valency with oxygen, and they form this sodium aluminate.
So Rachna is also saying they form sodium aluminate. See, the thing is, aluminate is a separate ion, which actually children are not familiar with. So it's like there is another complex ion forming. So you have to like draw attention to the children that this is something very special happening here. That a metal.
Sorry to interrupt. I would like to share one story that happened just few days before. I was in my this apple orchard, and there is a disease called black rust. And for black rust, we spray that potassium hydroxide. 1% potassium hydroxide we spray, and black rust is controlled. And one of my neighbors, just I was with my brother, we made the solution in a plastic container and then sprayed it. And one of my neighbors, he also made the same solution, 1% solution in this plastic container, and he just put this aluminum rod for shaking that solution. And to his utter
Wow.
surprise, the rod was that
Oh my
disappeared
God.
out of his hands. He told me, "Oh, you master, come here. What happened?" I told him, "Yeah, you have done a big blunder. You cannot understand that what happened to it." So there came chemistry. It is a big joke, and also this reaction that happened in before my eyes. It's just few days before,
Yeah,
just
yeah.
20 days before.
Only chemists can understand this, nobody else.
Yeah, I told him that I will never make such a mistake as you have made.
Correct. So the thing is, see, to teachers, my submission is that this is already written in textbooks, and
Yeah.
typically a child would simply mug this up. So metal plus acid, this happens. Metal plus base, this happens. Just rote learn, memorize, and write it down. But as a chemist, the teacher's the responsibility is to draw attention to the fact. So look, this is not a normal, usual reaction happening. Something very strange is happening. There's already one metal ion, which is sodium, which remains as in its ionic state. Here is aluminum now combining with oxygen to make another negative ion. See, aluminate or zincates are negative ions. So metal actually participates in a negative ion. I mean, isn't that surprising? So that surprising thing, that strange thing about chemistry should be brought out. That's my submission. I'm a non-chemist. And that's why I'm provoking all of you that you should actually make children see the surprise of it. Amazing. I mean, another metal comes in, makes a negative ion, not a positive ion. See, we have hammered it into children's heads that metals make positive ions, right? And here comes a metal, combines with oxygen to make a negative ion and goes and attaches itself to sodium, creating sodium aluminate, and a lot of hydrogen comes out. So, I mean, surprise of surprises, right? So, yes, so my request is only that. Okay, please carry on.
Okay, let me just share my screen. So as you were discussing, if there is a reaction between base and metal, so what would happen? Here we have taken sodium hydroxide and aluminum. So let's see. Okay. So for the reactant, we would need sodium hydroxide, which is in the bottle. Then we have taken a conical flask, and in this conical flask, we have taken some sodium hydroxide. Now in the dish, there is aluminum foil, so just a little pieces of it. So if you take the conical flask with the sodium hydroxide in it, and we will put a little bit of aluminum foil in it, and then we will see what will happen. So here also, as you will put the metal or the aluminum in the sodium hydroxide, you will see the bubbles will start forming. And if just to make sure, okay, the gas is being collected in the flask, so you just cover it for some time. And after some time, even when you will even touch the flask, you will see it's quite hot. So it's an exothermic reaction. It becomes very hot. So you have to be very careful while doing this. And now, just to check, you can show the children, or you can see there are quite bubbles of gases. So it's mean like there is a good amount of gas has been collected in the flask. Now to check which gas is it, as we did in the last video also, the last experiment. So here we have not taken the agabatti, we have just taken a matchstick, and we will put this into the flask, and again it will give a flash and there will be a pop sound. So it shows that the gas which is collected was hydrogen. So here also you can collect and do as per your comfort. So
but this reaction actually happens with quite a loud noise, and inside the conical flask, and a very beautiful pataka. I mean, like children, when we were doing this with children went crazy with excitement. I mean, they wanted to every time, like the gas keeps coming and keeps collecting. So they want to collect more and burst it again, collect more, burst it again. But it's like safe because the flame goes inside. It goes inside the conical flask, doesn't come outside. So it's not even dangerous for children. So here I want to see if Manisha, I have passed on the link to of that the universal indicator changing colors with dry ice. You want to show that? That see if you can run it. I've passed on the link on WhatsApp.
Actually, make me co-host, no?
I will. I will. You're able to run it?
Sorry, it's not possible for me. I will try again.
So what we'll do is, Preeti, you can carry on. Manisha will try meanwhile.
Okay, ma'am. So this is just the chemical equation for the reaction. आपका sodium hydroxide and it's the aluminium as we have in the chat, this forms sodium aluminate and hydrogen gas. So now if you will look at sodium aluminate, sodium it's still Na positive as it was in sodium hydroxide. Just aluminium, it has formed a negative ion, an ion that is aluminate. So that is what kind of differentiates. That's why there are no, like, not many examples for this bases reacting with metals. These are just few. Aluminum is one, zinc that is most commonly another example that forms zincate. So these are just quite specific properties of aluminum and zinc. That's why they form aluminate and zincate and even give reactions with bases. So not like all the metals won't do it. Just aluminum and zinc you will find. Now what about metal carbonates or hydrogen carbonates? So in carbonates, as you will see, so you can even ask, okay, if there is carbonate, sodium carbonate, so what ions will be formed if they are dissociated? So there is sodium plus sodium ion, and there is carbonate, which is CO3 2 minus. Similarly, if sodium hydrogen carbonate is taken, so what ions will be formed? So there will be sodium ion again, and there will be hydrogen carbonate. So if now we have to guess, okay, so there is carbonate ion, or if there is hydrogen carbonate ion, and you put an acid to it, you take acid and carbonate. So then what will happen? What will be the reaction? What is coming from acid? And if it's coming from acid, then how it is reacting with carbonate ion? What is being formed? So you can put the responses in the chat. just see the ions, which ion is from acid and how it will react with carbonate ion or hydrogen carbonate.
You can also speak and tell.
Yeah. So which ion is coming from acids? As we discussed in the beginning, like what are acids if they dissociate? So what ion do they give, which is the common ion between all the acids?
Yeah, so friends, just see, I mean, we are deliberately asking you, we do not want the textbook answer, what is written in the textbook that, I mean, okay, metal carbonates and bicarbonates combine with acid to give this. No. Instead, what is the ion that acid is giving and what is coming from here? What is happening? So, what is the ion that acid is giving, which Priti is asking? Very obvious answer. See, I suppose people are confused because the textbook doesn't show, teach it this way. It just gives the answer straight. So, I mean, very obvious. Which ion is coming from the acid?
If we
H plus
take
ions.
HCl, we will get H plus and Cl minus ions.
Hydronium ions
Right,
and
correct.
chloride ions.
Yes. So, hydrogen ions and chloride ions. Now, hydrogen ion will combine with what here? Suppose we take the upper one, sodium carbonate. So, hydrogen ion will try combining which one? With
carbonate.
exactly, with carbonate. So the first thing we get is H2CO3 actually. So we get H2CO3 there, and the chloride ion will combine with what?
Na+.
Sodium
Sodium.
ions.
Sodium ion. Yes. So actually, if you teach it as recombination of ions, it's very simple. It's straight. So Preeti, please carry on. I mean, like I just wanted to say that you can help children see through this. So now what happens next? Preeti will say.
Yeah.
So that's the combination that is happening. Yeah.
So if like from any acid, we will have hydrogen ion, and hydrogen ion will combine with carbonate ion, which is like negative ion, and it will give H2CO3, that is carbonic acid. And further on this carbonic acid H2CO3, it will just break into CO2 and H2. And it can also be like shown with the paper clips. So they will get a better idea. Okay, these ions are combining and eventually the carbon dioxide and the water is coming from there. Similarly, you can do for sodium hydrogen carbonate. If there is HCl, so what will happen? What will be the ions? Which ions will combine together? So here again, Na positive, which will combine with the negative ion of acid. Here it's chloride, so NaCl. And HCO3, that is hydrogen carbonate, negative ion, and the H positive. So they will again give H2CO3 and it will break into CO2 and H after.
Yeah, so the point is the thing that needs to be actually told to children is that this carbonic acid H2O3 is a very weak acid. It breaks up into carbon dioxide and H2O, and actually we see it also in soda water. I mean, like some of it actually becomes this H2CO3, but this reaction seems like a mystery to children. I mean, like why is carbon dioxide and water generated here? I mean, like, so an ordinary child will simply mug this up. So, okay, it seems as if something very special is happening with carbonates and bicarbonates. Nothing special is happening. It's the same reaction. It's just that now this H2CO3 is breaking up into two of its parts. So that's all. So if this one single step, by introducing this simple step, H2CO3, you make the thing, you open up the thing and make it simple to understand. And that's the difference between teaching where we just simply force the children. That's what textbooks do. Sadly speak, textbooks present is as carbonates and bicarbonates combining with acids and giving salt and water, and CO2. Now a child will think, where is the CO2 come from? And then they say that carbonates behave as bases. So for a child, this becomes a mystery. Why is carbon dioxide here? Why should it come? Right? So that is something we should help children understand. Yeah.
To sum it up, as it's given in the books, as Anshubala ma'am just said. So if we have to summarize it, so metal carbonate, when it reacts with acid, it gives salt, carbon dioxide, and water. And we just saw how like carbon dioxide, where is it coming from, and how the water is being. So both of these react with acids to give salt, carbon dioxide, and water. Okay. Now to move
So
forward,
it is
we have
social aspect of chemistry.
sorry, sir.
It is teaching social aspect of chemistry. These molecules and these species, they do have their social life. They interact as we interact with our friends. They exchange friendships.
Yeah, so there is like every kind of ion or every species, they have different affinities, they have different reactivity, and based on that, yeah, they
Yeah,
do.
ma'am, they have their social life, I think. Matlab, we
Yeah,
may
you
say
can
to the children,
say.
because
We can.
this will further help them in understanding the speciation, so different creation and creating and breaking of different species in big reactions when they come to higher classes. So this will leave a big foundation, strong foundation. If we teach via these methods or these concepts.
You can use it as an analogy, but finally, I think they should have a clean chemical understanding. I mean, there's
Yeah, definitely,
this is not.
definitely,
Yeah.
definitely.
Yeah. Please, Preeti, carry on.
Okay. So here we are discussing a metal oxide. So here it's MgO, magnesium oxide, and we have taken hydrochloric acid. So now we can ask, or you can just like tell me or put in the chat box. Now there is magnesium oxide, there is hydrochloric acid. So if there is a reaction between the two, so what will happen? Again, you can see the ions, okay, which one will be taken from where and what will be formed.
The acid will release H plus ions.
Which will
Remember,
combine
you were
with
saying
what?
acid will release
Will
hydrogen ion.
combine with the oxide and forms water.
Okay. Yeah.
Now the magnesium ions are left over with chloride ions.
So here also you can take the help of the clips or just show, okay, metal oxide like MgO, it has Mg2 positive, that is positive ion, magnesium ion, and oxide 2 minus, which is negative. And in acid, what will the positive ion? This hydrogen. And so which ions will combine? So magnesium will combine with chloride ion, it is positive and negative ions. It will give salt, magnesium chloride, and the hydrogen from acid will combine with oxygen from metal oxide, and it will form H2. So now I'm not showing the video, it's just this example, okay, how metal oxide they react with acid. So because this reaction is the same as base was reacting with acid, similar products were being formed, salt and water. So from here, you can kind of conclude also that metal oxides are basic in nature. They are behaving like acid. They are reacting with acid and kind of neutralizing them. They're giving water and so. This is just another example of non-metallic. So non-metallic oxides, how do they react with base? So we can even ask, okay, non-metal oxide, so now will it react with an acid or a base? So here we have taken example of CO2, carbon dioxide, and sodium hydroxide. Again, if you will look at the ions in the both, the reactant CO2 and NaOH. So from NaOH and CO2, it will react. Again, we will get salt and the water. So from here also, we can take the conclusion that non-metal oxide, they behave like acid. So they are acidic in nature. So this was so far about acids and bases. What are they? How do they work? How we kind of come to the pH? How we can compare the pH of the different substances? How we can use indicators to compare the substances? Now the reactions of acids and bases, just because of the ions that both of them give in the solution. So the reactions are kind of directed as per that. This is just a discussion of strong versus weak. If we say, okay, this is strong acid, this is weak acid, or this is strong base, this is weak base. So what do we mean by that? So as we compare, as we saw in pH, the one which will give more hydrogen ion. And to give more hydrogen ion, it means it has to break very efficiently. If it didn't break very efficiently, it will give good concentration of hydrogen ions, and we will say, okay, this is strong acid. So an example of strong acid is hydrochloric acid. If we take hydrochloric acid, so there will be good amount of hydrogen ions and chloride ions obviously from there. But if we take acetic acid, so yeah, dissociation will happen. Hydrogen ions will be formed, but not as much. The dissociation or the forward action won't be as much. So we can say that's weak and that's strong. Another comparison that can be done in terms of qualitative is concentrated acids, dilute acids, or concentrated base or dilute base. As you saw, like in the videos, it was written, okay, this is dilute HCl, or in some cases, this is concentrated sulfuric acid. So what's the difference between the two? This is the quantitative. So if we have taken a fixed amount of the acid, so how much is the concentration in that? So to show it kind of in picture form, as you will see on the left, so the area, it's the fixed in like all three cases, but here you will see like many particles in this. But as you diluted like in the acids or bases, we can do with the water. If more water is put into it, so now in the same volume, in the same area, the number of like H plus ions or the hydroxide ions in the case of bases, they are decreased. So even if we take like 10 ml, 10 ml, 10 ml, the concentration of hydrogen or hydroxide is decreasing. So where it's less, that's diluted, and where it's more, that is concentrated. So that's it from our side. Any questions you have so far? Or any suggestions, any feedback? How was it? Because as we take it like for children, so yeah, there today also we got quite good stories and examples how you are doing. So yeah, these things help, and obviously like there is betterment every time we do. So any feedback, any questions from your side?
And I see Miss Anjum Karima is also there today, and at least, I mean, like some people are familiar, but not very many. It will be very nice if you can start your videos so that we can at least see who all participated today. I will stop the live streaming.